Hello and welcome back. So I think I've got my face in a good spot that it won't disrupt, but if the camera has to move around, I'm sorry. So today is going to be the Module 7 review. And for those of you who may not have been paying too much attention, the main thing we were discussing was linear equations. And what the linear equation was we had y equals mx plus b. And our plus b, that turned out to be the y-intercept, or where the line actually crossed the y-axis. And then m was our slope, which we defined slope as rise over run. So this was virtually everything you needed to know about Module 7. But I'm going to throw in some test-taking tips. You see, just because you know everything about the y equals mx plus b and linear equations doesn't mean that's the only way to solve the problem. And let's be honest, in today's society, a lot of what we are measured about is our ability to take a test. I want to teach you some techniques for taking the test. There's always two ways to solve a math problem, especially when I have choices like A, B, C, and D, because that means they gave you the answer. You just have to eliminate which ones aren't the answer. So let's begin, shall we? So here we have a fish swimming at a constant rate toward the ocean floor. The equation, well, it said the equation, so that seems kind of important to me. The equation y equals 7x minus 3 can be used to represent this situation where y is the depth of the fish in meters below sea level and x is the number of seconds the fish has been swimming. Okay, so I can use y equals mx plus b to build this equation. And let me just go on ahead and rewrite it out. Y equals mx plus b. And this way we can kind of remember. So the plus b, that is my y-intercept. That is going to be the location where it intercepts the y-axis. And it does this at -3. And now my m is my slope, and that is defined as rise over run. And in this equation, my slope is -7. So that means I have a -7 on top. Well, -7 divided by what equals -7? That's right, 1. So that would mean for every 1 I go over, I am going to rise -7. A negative rise would mean I go down. 1, 2, 3, 4, 5, 6, 7. And so it's going to give me a line that looks something like that. Now, I didn't draw it quite straight, but that's okay. Now, from this, we can really piece together a lot of the information. And I wanted to give you the visual representation, even though you don't necessarily need it. So everything over here is negative time. Unless you've built a time machine, negative time doesn't exist. So I don't even need to worry about that. The fish starts right here. And where is it at? It starts at a position of 3 meters below. Well, if I look at my answers, the fish from a starting position of 7 meters. Nope, that's not right. The second one, from a starting position of 7 meters. Nope, that's not right. So I know those two are out. And that leaves me from a starting position of 3 meters below sea level. The fish is descending 7 meters per second. And from a starting position of 3 meters below sea level, the fish is ascending 7 meters per second. Test-taking tip. There will always be two answers that are really, really close. In this case, the word is descending and ascending. That is the only difference between C and D. Well, what does descending mean? Descend. I'm descending in the air. That means I'm going down. The fish is going down. Therefore, C is my answer. And just so that you get a little bit of words, ascending would mean going up. Ascension, to rise. Okay? So, test-taking tip and vocab lesson, all in one. Let's look at our next problem. So number 2, A pilot takes a taxi from the airport to the hotel, and the taxi driver charges $2.50 initial charge plus $2.65 per mile. Okay, so I have a $2.50 initial charge, and then I've got $2.65 per mile. Okay, which equation can be used to find y, the total cost of the trip, if x represents the number of miles of the trip? What does per mile mean? Per. Doesn't per imply multiplication? It does. So if I was putting this together, I know my equation is going to be y equals mx plus b. Where's the only multiplication I'm doing? That's right. I'm multiplying its slope. So I know that I'm going to put the 2.65 right here next to the x. Well, if I traveled 0 miles, so if I put a 0 in here, I'd still have this initial charge of $2.50. So that means I need to add the initial charge to the total cost. Well, there's my equation. 2.65x plus 2.50. Oh, but I bet you the test is going to do something tricky. 2.5 and 2.50 are the exact same thing. So if you saw 2.5, that's the same number, right? Cool. Let's look and see if we can get to number 3. Oh, I love these ones. These are so cool. So the table shows the distance, and you know what? I'm not even going to read it. Here's why I'm not going to read it. They gave me x and y in a table. I know they did because it says right here, x and y. All right. So I know this is nothing more than an in and out table. I am going to do something to x that will get me to y. So I just have to figure out what it is. I could do a lot of math and think to myself, what is all of the different relationships here? I know we're supposed to be talking y equals mx plus b, and I can figure that out. Or I can use a cool trick. Substitution. So most of the time in the real world, I can't substitute because I don't have a known good answer. But on standardized tests like the STAR test and whatnot, I can always use substitution as a test-taking device because they have to give me the right answer. One of these choices has to work, and sometimes this can be quicker. So let's try. And what we're going to do is we are going to substitute 5 for x and see if our y equals what it should equal. So y equals 5x. Well, this implies 5 times x. I'm substituting it, so it'd be 5 times 5. 5 times 5 equals 25. 25 is not 470. I know it's not A. And I'm going to substitute 5 for x here. 5 plus 5 is 10. 10 is not 470. I'm going to substitute again. 5 plus 470 equals 475. And while we were close, that is not 470. So now I'm left with 94 times 5. 5 times 4 is 20, carry the 2. 5 times 9 is 45, plus 2 is 470. That means my output is 470. That is the number I was looking for. Congratulations. You just found it, and you didn't have to do anything with y equals mx plus b. Sometimes you can outsmart the test with simple substitution. Numero 4. A store sells new video games for $55 each. That seems important. Let's go on ahead and highlight that. Used video games are $12 each. That seems kind of important. Let's go on ahead and highlight that. Jacob is buying 3 new video games and X used video games. Okay, which equation can be used to find Y? Well, look, they kind of jumbled up the information, but when we color coded it or we made some annotations to help us figure it out, that becomes really easy to put together. I need to figure out what the total cost of new video games is because I actually know he bought 3 of them. So if I am buying 3 of something, I know they're 55 each, I'm going to multiply that. So 3 times 5 is 15. I carry the 1. 3 times 5 is 15 plus 1, so 165. So I know 165 is my fixed amount. Well, really at this point, I kind of already know the answer, but let's keep going. And then I know that I've got $12 each. So I multiplied over here, so I want to multiply again times x. Well, how did I represent multiplication in the algebra problem? Well, 12x. And now I just have to add in this addition problem down here, and I've got 12x plus 165, and 12x plus 160. There's only one of them. But I really kind of knew that up front because it gave me this 165, and so I knew it wouldn't be plus 55. I knew it wouldn't be plus 12 or plus 12. So I didn't have to do that last step. I went on ahead and did it because, I'm an overachiever and I want to make sure my answer is right. Number 4. Oh, this one's really cool. I love it. When they give me tables and graphs, I know straight up I really don't have a whole lot of reading to do because I have time and cost, and it actually straight up says, actually, I want to change the colors. It straight up tells me I have time of y and cost, or time of x and cost of y. So I can go on ahead and plot these. Now, remember, it is very, very important that you remember x, comma, y. That is the order they are read in. X goes left and right, y goes up and down. Okay? So if I was to look at this, x is 1. Well, there's not even a 1 on my x. There is a y. Well, let's go for it. And let's say that we went backwards on this one and we got 1 and 32. Okay, maybe. Doesn't seem right, but maybe. Now down here, I got 1 and 32. That doesn't even line up on the line at all. It's way off the line. I know that's not an option. 1 and 32. Again, that's not on the line. Way off the line. And now I'm going to look at D. 1 and 32. That's on the line, and that made more sense because my x actually went to 1. Okay, let's try again. 3 and 56. 3's not down here. It's on the side, so 3 and 56. That kind of, again, it just maybe, but not quite. And then I've only got the one other option. 3 is on my x, and it goes up to 56. All right, 5 and 85 and 80. But again, this is, it's not my x and 5 and 80. So those all match up, but the x and the y are backwards. And then let's look. Time, hours. And this is time, hour. Oh, yeah. It's all wrong because the time is actually represented as the cost. It's not A. It's going to be D. And that is, yep, look, time is 1, 2, 3, 4, 5. Cost goes up to 80, so cost goes up to 80. Yep, it's D. Notice how little math I actually did. I really just took the graphs it gave me, the data it gave me, plotted it on the chart, and found the one that lined up. Test-taking strategies. Oh, check this. These are even funner. Again, funner. Even funner. English teachers, don't yell at me. I teach math. What's the technique I can use for this? I mean, yeah, y equals mx plus b. I can tell that plus b is going to be my y-intercept, so I know that that occurs at 0, 14. But let's be really simple with it, okay? Let's use the other trick. Substitution. So we're going to substitute our x's. So I know y equals 0.5 times, because that's what this is implied right there, is a multiplication, x of 0 plus 14. Okay, 0.5 times 0 is 0 plus 14. 0 plus 14 is 14. So if I put in a 0 for x, I should get out 14. It gave me a 0, so that's not it. 0, 14, okay. Input of a 0, output of 14, okay. Input of 0, output of 14. Okay. Now, who among you truly loves decimals? Like you go out of your way to work with decimals. Yeah, me neither. Let's not work with this one. I just don't want to. I'm lazy. But look here, I got 10 and 19. Those are nice round numbers. Let's see what happens with those. So y equals 0.5 times 10 plus 14. Well, 0.5, isn't that really just saying 1/2, 50 cents, 1/2 of a dollar? Okay, well, 1/2 of 10. That really makes that math easy. Half of 10 is $5 plus 14. 5 plus 14 is 19. So if I put in 10, I should get 19. Put in 10, get 19. That works. Put in 10, got 64. That one's out. Put in 10, got 15. That one's out. And with two simple substitutions, I have discovered that my answer is H. Moving on to number 7. Now with number 7, we actually need to know a little bit about y equals mx plus b. I need to know that m is slope and the plus b is definitely my y-intercept. And that's easy enough because the y-intercept is the point at which it crosses the y-axis. And on this problem, my plus b is going to be a positive 3. So I know I have y equals something x plus 3. And now with that information, I can look down here. I got -1. I know it's not b. And I got a -1. I know it's not d. So that means it's going to be either a or c. All right, so all I got to really clarify at this point in time is my m, my slope. And as we know, my slope is going to be rise over run. So I just find another point on this graph. I'll let right here. That looks convenient. Figure out how high I'm going, how far I'm going over. And I am rising 1, 2, 3. So my rise is 3 over my run of 1. 3 divided by 1. Well, 3 divided by 1 is actually just 3. So I'll plop in the 3 there. So 3x plus 3. Oh, and look. Yep, they were trying to get me to go run over rise. I know it's not run over rise. It is rise over run, which means y equals 3x plus 3 is certainly my answer. Let's see what number 8 has. Oh, look at that. Number 8, I got a data table. That means that straight up, let's just use the good old-fashioned substitution trick. No reason to break out hard math whenever we know we're getting the answer. So that means I've got to in and out. I can substitute x for 0, and I should get 4 for y. And again, 2x, you know this is implied multiplication, so 2 times 0. 2 times 0 is 0, plus 12 is 12. That is not 4. 4 times 0. 4 times 0 is 0, plus 6 is 6. That's not 4. Oh, and look, we have 2 answers that are close. There's always going to be 2 answers that are close. 2 times 0 is 0, plus 4 is 4. This is a maybe. 6 times 0 is 0, plus 4 is 4. That one's a maybe. So let's move on and try another one. 2. 2 times 2 is 4. 4 plus 4 is 8. Nope, that's not what I was looking for. And now, because I want to make certain I'm right, let's go on ahead and try it in the last one. 6 times 2 is 12. 12 plus 4 is 16. That checks. J is definitely going to be my answer for number 8. Moving along. Number 9. Oh, this one looks a lot like that taxi cab problem we had. So Nicholas is buying shirts for his baseball team, right? And he will pay $9.50 for each shirt. and then he will pay plus a one-time fee of $22.50 for the design. If I was writing a math problem, and I am writing a math equation at this point, what would it be that each means? If I'm paying $9.50 for each shirt, what kind of math do you think each is? If I was paying $1 for each card, right? If I was paying $1 for each card, and let's say I wanted to buy the Ace of Hearts. Hey, on test day, write down Ace of Hearts on your answer sheet. And if you're a remote tester, shoot me an email with the 8 of hearts. I said ace, 8 of hearts. And I'll give you 10 extra points on the test just for going the 8. But if you wanted to buy 2 cards for $1 each, how much would it be? $2. 5 cards, $5. What's the math you're doing right there? You are multiplying. Okay, so $9.50 for each shirt means I am going to multiply some number by 9.5. So my beginning of the equation should look like 9.5x. Well, that means it's definitely not B, and it's definitely not D. And remember I said that I'm always going to have 2 that are going to look very similar? Well, they both have 22.5, but I have a plus and a minus. But look at the problem. Plus a one-time fee. It's already told me I have to add that fee to whatever the cost is. It flat out told me the answer is plus 22.5. Number 9, the answer was actually in the question. Our last one, 10. And 10 hits kind of hard because we do have to know how to use y equals mx plus b. But again, we already got this down pat. It's simple. Plus b is where it intercepts the y-axis. On this occasion, it intercepts at -3. So my equation will be y equals something x minus 3. Oh, and look, that means h is out and j is out. Straight up. So now I just need to figure out my slope. And we know that slope is rise over run. And so I'm going to look for a point where it actually intersects. And it looks like it intersects right there at -4. So I just have to figure out my rise and my run. And so I'm going to go down 1, 2, and 3. Because I'm going down, that is a negative rise. It's the opposite of actually going up. And now my run, 1, 2, 3, and 4. So my slope will be -3 over 4. And, well, now it's clear as day. F is my answer. You know, this is kind of down and dirty, and it assumes that you were in the class and everything because this is a review. But if you have questions and want to learn more about slope and linear equations, I do have videos for those. Please feel free to watch them over and over and over. Leave a comment. Let me know what you thought. And yeah, by the way, 8 of hearts. Remind me during test day. 10 extra points. Don't forget to comment, like, subscribe, hit the notification bell. I'll see you in class on Monday. Maybe. The weather's been looking like it might be snowy. So you bundle up, you stay safe and warm, and I'll see you in class when I see you in class.